photography dealer ordered 60 Model X cameras to be sold for $250 each, which represents a 20% markup over the dealer's initial cost for each camera. Of the cameras ordered, 6 were never sold and were returned to the manufacturer for a full refund of 50% of the dealer's initial cost. What was the dealer's approximate profit or loss as a percent of the dealer's initial cost for the 60 cameras? Step 1, understand the structure that you're going to use here. And the leap I'm going to make right now is kind of a big one for a lot of people, but the easiest way to do this problem is to realize that the structure that will work here is about combining unequal quantities into an average, right? Because we want to know the profit or loss on average, or overall, for the 60 cameras. And we've got some of them that are sold for a 20% markup and some of them that are returned for a 50% loss. So if we could just put that into a weighted average formula, that would be the easiest way to do that. Let me explain briefly. The weighted average formula I use goes like this. Part A plus part B equals part of A plus B. And the reason I use this formula, written out this way, is that these allow me to use all multiplications to calculate an average. I never want to divide if I don't have to. And here I can just look at it and say, okay, I have some quantity here. So this is a quantity or a weight. Same here and same here. So like in this case, I have 60 total cameras and I have 54 that were sold and I have 6 that were returned. Those are the weights. And then the weighted average is used to average out the thing you care about. And so you say, well, what's the thing I care about in this problem? It's profit or loss. And so those 54 cameras had 20% profit. So I can just say, okay, 20% profit. These 6 cameras were returned for 50%, so these ones had a 50% loss. And then the final profit, well, that's what we don't know. So this is just going to be X% profit or loss. And now I've got a one variable equation I can just solve to get an answer here. This is how the weighted average formula works. It's saying, let's take this 20 and prioritize it 54 times. Let's take this minus 50, and let's only give it 6 priorities. And then together that's going to balance out and get us some weighted average profit or loss on the whole group of 60. To deal with this, the first thing I would do is I would realize that I can get rid of these percent signs because I have 3 terms and I have a percent sign in each of them. Some of you might prefer to write these as fractions. I know I prefer fractions to percents. And if you do it that way, you can just think about this as multiplying the whole problem by 100. Either way, they all go away. Next thing to think about, 20 times 54 minus 50 times 6 equals X times 60. Well, it strikes me that I've got a 0 in each one of those. So if I divide this whole thing by 10, 20 just becomes 2, 50 just becomes 5, and 60 just becomes 6. We could write it out at this point for clarity, although there's one more algebraic simplification I want to make as part of this reduce before you multiply principle. 2 times 54 minus 5 times 6 would equal X times 6. And so yeah, I could calculate, but if I spot that I've got a 6 and another 6, and then I've got a 54, which is a multiple of 6, I could also divide this whole thing by 6. So I'd lose that 6, and this would become a 9. Now I've got a problem I can solve easily. 2 times 9 is 18, minus 5 equals X, or X equals 13. And since it's positive, that means it's going to be 13% profit, because what loss is really just negative profit. That's the easiest way to do this problem. I want to circle back though and look at the fact that you can do it without that. You can do it without using that weighted average formula. You might find it a bit easier to do so. So, approach number 2. Rather than using a weighted average formula, we can say, let's not use this 250, let's use a different value. You might pick up on the fact that I never had to use 250 in the way I did this first. But even if you were to use a value, it doesn't have to be 250, because this is one of these arbitrary things they've made up. And the first thing I'm asked to do is to say 250 is 20% more than what, which is actually a kind of annoying calculation to make. So instead of doing that, I'm going to say, let's just say, how about the original cost is $100? That seems pretty simple. So then, I bought 60 cameras at $100 each. I spent $6,000 total, or the photography dealer did. I'm getting into this photography dealer's shoes. Maybe I secretly want to become a photography dealer and quit this whole GMAT thing. We'll see how that works out for me. Photography dealer ordered them $100 each, and I just made this up. And then we said, okay, we sold 54 of them at a 20% markup. So there are 54 of them that rather than 100, we're saying plus 20%, means those were $120. And so how much profit did we make on those ones? We made $20 profit on them. So 54 cameras got $20 profit each. Then 6 were returned, and so we lost 50%. So we want to say minus 6 times $50 loss on each of them. And then we're saying, okay, so what is that profit or loss as a percentage of the initial cost? Well, here's our initial cost, $6,000. Now we just need to do this math. And before we do it, though, we can set it up and reduce. We can say that's 54 times 20 minus 6 times 50 all over 6,000 is going to be the fraction of our initial money. And to get a percent, we just need to multiply it by 100, right? Because this is what we just figured out is the profit. 54 times $20 each minus 6 times the $50 we lost. And so that's the numerator, and 6,000, the total amount we spent, is going to just go down there. And so if we set this up as a fraction, first step is that we can reduce. We cross out the 100 there, and then we can say, okay, cross out the 0 and the 0 and the 0. And once again, we can keep crossing out. It's the same math as before. We've got a 6, a 54, and a 6. So we can cross out the 6, cross out the 6, and make this a 9. We're doing the same math we did last time. 9 times 2 is 18, minus 5 equals 13. And so that becomes a 13% profit because it's a positive value, once again, that we got here. And once again, luckily, consistently, the answer is still D. So that's 2 ways to approach this problem. Both involve some lessons, and let's talk about those. First one is recognize the weighted average. It's the same thing you'll use for a mixture problem. It's anytime you're combining unequal quantities of things, right? And so this formula, it's one of my top 5 favorite formulas for the GMAT. I would highly recommend memorizing it and learning how to use it. And it could be used for more quantities too than A and B. We would just add C in to both sides of the equation. But the idea of it is, if we're saying I've got 10 gallons of a 5% alcohol solution, plus we'll say 15 gallons of a 10% alcohol solution, then that's going to be X% for the total 25-gallon solution when I mix them, right? And we could solve for that. But note, you could have anything be a variable. If I say I want the solution that we come up with when we mix them to be 8%, then how many gallons of the second solution do I need? And then we have a 10 plus X total. So you can always just leave one variable out of it. Super useful formula. We'll come back to this one and use it other places. Second tip, making up a total. It's what we call put for problems with unknown totals. But there's another name for it too. And it's still put. Because in this case, it wasn't that the total was unknown. It's also that it's a problem with an unwanted total. And this $250 as the initial price for the camera, ignoring that saved us a lot of effort. And then next rule to think about here is the constant reminder, reduce before you multiply. And as you saw, we could have figured out 54 times 20 minus 6 times 50. And And again, not the end of the world to do this. 20 times 50 is going to be 1,000, plus 4 times 20 is going to be 1,080, and then 6 times 50 is going to be 300, so it's going to be minus 300 equals 780. We can do that, but we shouldn't, because it's better to just say 18 minus 5 equals 13, and that's the kind of work that reducing before we multiply is going to get us. All right, thanks again for following through with this. This is one of what I believe are the 10 toughest problem-solving problems in the latest official guide. There are tools that you learn from using these that you can apply to lots of places. And if you want more work on those tools, check out Test Crackers, check out our strategies, check out our other videos, like and subscribe to this channel so you can see when we create more content. Comment if you have questions about this or anything else, if you have problems you want to see or concerns you have. And otherwise, thanks for watching.